In this video, we'll discuss the applications of quadratic functions in business and economics. Now, we're going to be talking about revenue, costs, and profits. And you'll see a common equation, which is P of x equals R of x minus C of x. What does this mean? What we're talking about is that the profit is equal to the revenue generated minus the costs, all of that in terms of x, which are the units sold. Now, we're often looking at different types of aspects within this profit function, such as the break-even point. And this is when our profit equals zero. So we have two options on how to solve this, which include either setting our profit function equal to zero or stating that our revenue is equal to our cost and solving that equation. Do whichever is easiest for the given problem. Now, some other aspects that can be helpful with the quadratic functions when we're modeling is that the vertex will often represent the profit maximization of a given problem. That means that when you're trying to find the maximum profit, look for that vertex, especially if you have a negative quadratic function, because your parabola will be upside down and the maximum will be at that vertex. Another thing is to recognize that your break-even points can happen at one or two places, because when you think about a quadratic function, when it creates that parabola, it can cross the x-axis at one or two places. So that's why you have to double check for both break-even points. Now let's look at some examples to help out. Say a company produces batteries, determines that its cost function is C of x equals 80x plus 15,000, and its revenue function is R of x equals negative x squared plus 510x plus 3,000, where x is the number of crates of batteries sold each day. And we know what's the profit function for this company. So the profit function is the revenue minus the costs. So we take our revenue function and then we subtract our cost function. Now we're going to distribute the negative and then we're going to simplify this expression. So that becomes negative x squared plus 430x minus 12,000. Now another thing could be asked is what's the maximum daily profit by the company? That maximization of this profit equation means to look for the vertex. So I could graph it, and you can see it creates a very large graph, and I've got to zoom out quite a bit to get to where it's saying 215 crates are sold for $34,225. Now I can also do this algebraically. We start with the x value, where it's equal to negative b over 2a. So we have to stick the quadratic function back in general form and then use our coefficients in our constant. So negative b, so our b value is the x term, so it's 430, and 2a, a is the constant that's on, or the coefficient that's on the x squared term. That's negative 1. So the negative and the negative simplify to positive. 430 divided by 2 is 215. So that would mean there were 215 crates sold to maximize, and now we want to figure out how much that makes. So we take our 215 and we substitute it in for x. Now remember, because that's negative x squared, we square the 215 and then multiply by negative 1. And that'll give us negative 46,225 and then plus 92,450 minus 12,000. I keep simplifying. That gives me 46,225 minus 12,000, which is 34,225. And that matches what our vertex found. So what that tells us is that the maximum daily profit is selling 215 crates and earning $34,225. Now another thing we could ask is what are the daily break-even points? So this is where the function for the profit equals 0. So we look at our function and we're looking for the zeros. So we can do that by graphing the quadratic formula or group factoring. So if we graphed this, we'd be looking at where does the graph cross the x-axis, because that's where y equals 0. It happens at two places where the values are positive. Positive 30 crates and positive 400 crates. So at either of those places, that's where the profit will equal 0, and that's the break even. Now we can also do this using the quadratic formula. And again, it's got to be in general form because we say that 0 equals negative x squared plus 430x minus 12,000. So I substitute in negative b plus or minus b squared minus 4 times A times C all over 2 times A. I'm going to simplify it inside my radical first, and this will give me 184,900 minus 48,000, and my denominator is negative 2. Now I simplify again in my radical. That gives me to 136,900, and the square root of that is 370. So now I need to do plus or minus 370 to determine what are the potential zeros. So I add 370, which takes me to negative 60 over 2, negative 2, which is positive 30, matches with my graph here. I can also then do negative 430 minus 370 divided by negative 2, which is negative 800 divided by negative 2, and that matches the other point, which is 400. And again, both of those are positive, and in the context, that would make sense. I can sell 30 crates of batteries. I can sell 400 crates of batteries. Those numbers make sense in context. So we know the daily break-even points will be at 30 crates and 400 crates. So now what if you were asked P of 100, and what does it mean? This tells me I'm going to start with my profit function, and I'm going to substitute in 100. Again, remember, that's 100 squared times negative 1, and then 430 times 100. So this becomes negative 10,000 plus 43,000 minus 12,000. So that's positive 33,000 minus 12,000, which is 21,000. So what does that mean? That means that if 100 crates of batteries are sold, the company will make a profit of $21,000. Now we also talk about the supply, the demand, and the equilibrium of products being sold. Supply represents the availability of a given product, and demand is how much that product is desired. And the greatest influence on both is price. Now, when we graph them, we think about the overall quantity of a product being the X value and the price being the Y value. And then what we notice is that as supply increases, demand often decreases based on price and quantity. So we then have to compare these two together. We notice that shortages of a quantity occur when the demanded quantity is greater than the supplied quantity, whereas a surplus is when the supplied quantity is greater than a demanded quantity. So think about it. A surplus occurs often when you charge too much for an item and people aren't willing to buy it at that price. That's the easiest way to think about a surplus. The goal, though, is to find the equilibrium of the two, of when is it that the price and quantity produced meet both the supply and the demand for a product, and that becomes the intersection of those two functions. So when we're trying to determine that equilibrium point, we will be provided two functions for supply and demand, and we're going to solve them as a system of equations. Often these are complex models, and so we want to use graphing or substitution. If it's a quadratic function and we want to use substitution, that's going to require the use of group factoring or the quadratic formula. So let's look at an example. Say a company selling pants determines their supply function is 4P minus Q equals 112, and their demand function is P times the quantity Q plus 13 equals 630. Now, if the company sells the pants for $40, will there be a surplus or a shortage of pants? So let's start with each of these equations, and we're going to replace the P for price with $40. So let's start with the supply function. So that's going to become 4 times 40 minus Q equals 112. So 160 minus Q equals 112. Subtract the 160 from both sides, and then divide both sides by negative 1 so that positive Q equals 48. Now let's look at the demand function and substitute 40 in for P. First thing I would do here, since it's being multiplied by this quantity, is distribute. And that would become 40Q plus 520 equals 630. I would subtract the 520 from both sides, and then divide by 40 to get that Q is 2 7/75. Now I look at those two values and say, wow, 48 is much higher, so the supply has a higher quantity. And if I graphed it, what I would see is that the supply function's quantity is much further to the right. Since the supply quantity is greater, that means there's a surplus of pants. In other words, charging $40 is too much. People aren't going to buy them. So you're not going to be able to sell them. You're going to have more left in your warehouse. Now, what if we want to determine where does the supply meet the demand? In other words, where is that equilibrium point? The easiest way is to graph the lines. Just remember that we're going to substitute y in for p and x in for q so we can put it on the coordinate plane. So let's start with the first equation here. That would become, with the supply equation, 4y minus x equals 112. I would add x to both sides and then divide everything by 4 so that 1x divided by 4 is 1/4 x, 112 divided by 4 is 28. And I can easily graph that linear function then. Now I'm going to do the same thing with the other, and I would have y times the quantity x plus 13 equals 630. This is a little bit weirder for most people because of this quantity being multiplied. But I can divide both sides by the x plus 13 to get y by itself. And this is a rational function. And its asymptote is negative 13, but since we're dealing with supply and demand and finances and quantity, everything's positive, so that asymptote has no impact on the graph. So now I'm going to graph both equations and look at where they intersect. In this case, I have my positive linear function, I have my hyperbolic type curve, and I see they intersect at 830. This means that the equilibrium point is to sell 8 pairs of pants for $30 each, and that will meet supply and demand.